SpIRIT launches, a multinational corporation gets underway in polar orbit. Meet Roo-ver, Australia's first Lunar Rover, set to be launched by NASA for Artemis. And Blue Origin's 15-month spell on the bench is almost over. 21 corrective actions checked off. Now it's time to fly. It's Wednesday, December 13, 2023. These are the science and space headlines you need to know now. The University of Melbourne and the Italian Space Agency have announced the successful launch of SpIRIT, a landmark nanosatellite mission supported by the Australian Space Agency. The Space Industry Responsive Intelligent Thermal Nanosatellite, or SpIRIT, lifted off from Vandenberg Space Force Base in California aboard a Falcon 9 rocket on the 2nd of December and has now entered a polar orbit 513 kilometres above Earth. SpIRIT is the first Australian satellite to carry a foreign space agency's scientific instrument as its main payload, namely the Italian Space Agency's Hermes X-ray detector. Now, that instrument is designed to search for bursts of gamma rays, which are created when stars die or collide, and for a moment emit more energy than an entire galaxy. SpIRIT is the start of a network of 7 nanosatellites called the Hermes Scientific Pathfinder constellation that are looking for these cosmic fireworks. And after initial checks and communication with the Nova Systems ground station in Peterborough, South Australia, which started last week, continue for a little while longer, the coming weeks will see the shoebox-sized 11.5 kilo nanosatellite, which uses the popular CubeSat design, deploy solar panels and thermal radiators nearly 1 metre long. Researchers at the School of Physics and Astronomy at Monash University delved into the mysteries of radio waves emitted by the most massive black holes with the aid of the Australian Square Kilometre Array Pathfinder. And lead researcher, Associate Professor Michael Brown, is beaming in to talk about their findings. Professor, welcome to Talk in Science. What did you find?
G'day, it's good to be here. So we've been looking for radio waves from the really big galaxies for quite a while. And over 60 years ago now, they first started detecting some radio waves from really big galaxies, but a lot of the big galaxies didn't show any radio waves at all. And what's happened with the Australian Square Kilometre Array Pathfinder is we've been able to finally find radio waves from all of the really, really large galaxies, and that tells us something about the black holes within those galaxies.
Now, new stars in galaxies can also produce radio waves. How did you differentiate all that noise coming into ASCAP?
So one of the things that's interesting about the biggest of galaxies is they're often pretty much dead in some ways. They're generally not forming new stars, or not many new stars. And so they're basically great big footballs of old stars formed about 10 billion years ago, with a black hole at the center. And when you feed that black hole, you can get radio waves coming out.
Now, also tell us about how great ASCAP is, because we've been following the progress of the Square Kilometre Array project. It's been something that has been a long time coming and is a multinational cooperation as well.
Yeah, so ASCAP has been building up over the years, and we've just been using some of the early data from ASCAP. And one of the really fun things about it is that even with this preliminary data, this preliminary Sky survey, the rapid ASCAP Continuum survey, it's already about a factor of 3 more sensitive than the previous generation large area survey, the NVSS from the Very Large Array in New Mexico. And so that factor of 3 improvement in sensitivity has meant that signals from some of these massive galaxies that were originally sort of buried in the noise are now very distinct, clear signals. And that makes this result much more definitive than, say, previous works.
The study has now been accepted for publication by the Astronomical Society of Australia. What does that mean for you and the team?
Oh, look, it means a couple of different things. One thing that's kind of nice is this actually started off as an undergraduate project back in the COVID lockdown days. Tegan Clark, who's now a PhD student, did this when she was a third-year student, sort of did the preliminary work, showed the viability of the results, showed the strength of the data. And then we've sort of built on that work since with improvements to the ASCAP data processing and, really sort of locking this result in. And it's really exciting. It sort of leverages, it's going to leverage some future work. We've got some telescope proposals in for follow-up radio observations and follow-up spectroscopic observations to try and understand, why some of these really massive galaxies are emitting a lot of radio waves, but others are a lot less loud in the radio.
Very exciting times ahead, and plenty more research as well. It never stops, does it?
No. Anytime you answer a question, you end up with 3 more questions to answer.
I love it. Professor Brown, thanks for your time on Talking Science, and hopefully we'll hear more about these black holes in the near future.
Indeed, I hope so. And thanks for having me on board.
Meet Roo-ver, the result of a public naming competition that saw more than 8,000 entries for Australia's history-making Lunar Rover that NASA will take on a future Artemis mission to the moon. The winning entry was submitted by Siwa from New South Wales, who said the rover deserved a truly iconic name reflecting the Aussie spirit. Playing on the word kangaroo from our coat of arms seemed only fitting. The 20-kilo rover will be around the size of a piece of luggage, with the aim of capturing lunar soil samples to hopefully extract vital oxygen to sustain the lunar mission. With the new moon on the horizon, this weekend's Gemin meteor shower is set to be a cracking experience for those up in the early hours. The annual event, visible across the entire Great Southern Land, is predicted to be the best we've seen for a very long time, thanks to the absence of that pesky moonlight. And with 63 meteors an hour expected for those in the Northern Territory, it's going to be an awesome experience. For the past few decades, Earth has been passing deeper into the dust cloud of former asteroid 3200 Phaethon, and while it's usually the middle of the day for us when the shower peaks, this year it's going to be closer to its highest elevation on Friday morning. Overseas, and Blue Origin's 15-month spaceflight hiatus will finally end next week if plans continue on track. The Jeff Bezos-founded company has remained grounded since the New Shepard suborbital vehicle suffered an anomaly during an uncrewed research flight in September last year. That anomaly saw the capsule activate its emergency escape system to power itself away from the booster, which had suffered a thermostructural failure of the nozzle on the BE-3PM engine, according to the mishap investigation. New Shepard, the capsule, landed safely back on Earth with all 36 research payloads intact. 21 corrective actions to prevent reoccurrence were demanded by the US Federal Aviation Administration, which have now been completed, and the capsule is heading back to the West Texas launch site ahead of the December 18 launch window. Voyager I's transmitter is stuck again. The 46-year-old spacecraft, currently powering its way interstellar space, can receive but can't send. The flight data system has been identified as the problem. It's no longer communicating with the probe's telecommunications unit, according to NASA. The FDS handles the compilation of data into a packet for transmission by the TMU, but lately it's been stuck, transmitting essentially gibberish, a repeating pattern of ones and zeros. Engineers are now working the problem, and once they figure it out, it's going to be about a 45-hour round trip to know whether they were successful, thanks to that massive distance that's involved. Well, astronomers hunting for dark matter have stumbled across the longest trail of stars ever seen, stretching some 10 times longer than the Milky Way. Space.com tells us that stellar streams are elongated threads of gravitationally entwined stars that have likely been ripped away from their parent galaxies or nebulae by the gravitational pull of other nearby galaxies. Dozens of these streams have been mapped within galaxies, including our own, but none had been discovered in intergalactic space until now. The November 30 study, published in Astronomy and Astrophysics, shows how the researchers identified and mapped the stream, which stretches through the Coma Cluster, a group of more than 1,000 small galaxies located 321 million light-years away. The study's co-author, University of California astronomer R. Michael Rich, made the first observations with his personal telescope before the team gained time on the Canary Islands William Herschel telescope. Well, there's just 1 week left in our 20th year. Next year, bigger and better things in the world of science and space. Don't miss them. Trekzone Media is on Facebook, Instagram and TikTok. We're also a production company in Australia, so you can hire us from everything from live streaming to corporate work, not just in the space industry either. Jump onto our LinkedIn page to see what we're all about. I'm Matt Meller. This is Talkin' Science.